Hello everyone, welcome to Sunrise classes. Today we are going to discuss some of the addressing modes that is memory based. Earlier we already discussed about the addressing modes, what is the role of addressing modes, so how it is useful, and we already discussed in details about the register based addressing mode. If you have any doubt or any confusion, or if you did not watch that video, please go and watch the register based addressing modes in details. Today we are going to discuss some of the memory based addressing modes, uh, like implied addressing mode, immediate addressing mode, and direct addressing mode, that is also called the absolute addressing mode. So let's go to the implied addressing mode. In implied addressing mode, operands are implicitly specified in the instruction. What it means that, for example, this is the our instructions. We have two parts. One is the opcode and another is operand. So here it is saying operand. This part is implicitly specified. It means that in instructions this part is blank. So what is in operand? Operand, in sometimes if one operand instruction is there, there is a two operand instruction is there, three operand instructions could be possible. So what will happen if the two operand instructions, the right hand side, we know that instructions will be executed from this way. So right hand side will be the source and the left hand side will be the destination. So either destination was implicitly given, or source was implicitly given, or both was not given. So in that case only opcode will be there. So in this implied addressing mode, there could be possible 0 operand or 1 operand. I will give you the example for 0 operand. Let's take an example of CLC. What will happen if you just give the CLC as instructions? It will set the carry flag to 0. It will clear the carry flag. So it is a 0 operand. In this 0 operand only the opcode is there, and that is the CLC. It is a 0 operand. But there will be a for example add R2. What it means, we have to add R2, but where we have to store? So we have to store R2 into accumulator. So it will be like accumulator equal to accumulator plus R2. So this is implicit, that accumulate, we are talking about the accumulator. This is implicit. So this is called the one operand implied addressing mode. Now while executing these instructions, CPU know that which registers they have to use which registers they have to use to store the data, and what they needs to do. For example, if I am giving CLC, then he know that we have to clear the carry flag. So they have to clear some specific registers to 0. So that's why it is called, because the register was specific in this instructions, that's why it is called the register specific instruction. So implied addressing mode also called as a register specific instruction, because each instructions will specifying specific registers for the data, because operand is not given, data is not given. So CPU can understand from where they have to take the data and which place they have to store the data. Generally for arithmetic application and the logical operations, they will use as a accumulator to store the intermediate value or store the data. This addressing mode is also called the stack addressing mode. Why it is called as a stack addressing mode? Because we know that pop and push is there. From pop and push instructions, we don't need to say which which addresses, because pop know that the in a stack they have to pick the top element. So because of that, it is a specific to stack operations. It is called the stack addressing mode also. I hope it is clear. Let's talk about the immediate addressing mode. Immediate addressing mode, what it means, like we are going to give the data in the instruction itself. So in this case, again, CPU don't no need to go to the memory, no need to go to the register. It will simply, data is already there in the instructions, so they will just perform the instruction on the data. So you see here the example is AL has 35H. So this is the symbol we will use for the immediate addressing. So here you see the data is itself is given in the instruction. This is the opcode, and the here data has given. So for this, to get this one, no need to go to the address, no need to go to the register, no need to go to the memory. So this is called the immediate addressing mode. Remember this one. One more thing, this is basically we are using for the constant, because for example, if you have any programs and the value will be not going to be changed in the complete process. So if the value is not going to change, so simply we can pass that value. But what will happen, for example, a equal to a plus b we are giving. So here a value of a has changed. So we cannot use this as a immediate addressing. Okay. So in the immediate addressing, basically we are using constant. We have to use this symbol. And one more important thing, here it will be only comes as a source, because we cannot give this one in the destination. This is the destination and this is the source. So it will be always in the source, not in the destination, because constant will be destination. What it means, we cannot going to copy any other value into the destination. Na? Here we are going to read from the sources only, that's it. So it will be always part of the source. I hope it is clear. Let's go to the next addressing mode, that is the direct addressing mode. Direct addressing mode, also called as a absolute addressing mode. So what will happen in the instruction, in the instruction, this is the operand. In the instruction itself, we will give the address, effective address. So whatever the value is here, for example 0 1 something is there, so this will be, or maybe some location is there, yeah. So this will be the effective address. So now what we have to do, we have to go to the memory, that is the RAM, and using this effective address we have to go to the RAM, and then we have to find the data. So this is the data. So it's clear, from operand the value whatever is given, that is the effective address. So in instructions, what we will give, we will give the effective address. From effective address we will go to the memory. Here there is no role of registers, so we will go to the memory, we will find the data. You see this one. But what is the problem? The problem is here, if it's a 20 bits, then effective address will be 20 bits. It will become, instruction will become very lengthy. If for example two addresses we are giving, source and destination, so in this case what will happen, you know that there is a different type of instruction is there, in that there may be the 1 2 or 3 operand can be possible. So this is the opcode and this is one operand, this is another operand. So if this is the case, then the 40 plus 40, so 20 plus 20, so this is 40 bits only for the operands. So this will become lengthy instructions. So okay, let's discuss the example here. So what it is saying, add accumulator to 0301. So 0301 will be the effective address. So it will go to the RAM, and from there at 0301 they will find out the data. I hope it is clear. Next, go to the another addressing mode, that is the indirect addressing mode. Let's talk about the indirect addressing mode. In indirect addressing mode, in the instruction we will give the one address, that is the address in the RAM from where we will find the effective address. So in direct addressing mode, this one is a effective address, but in indirect addressing mode, this is the address where the effective address is there. So this is the effective address, and from here we are finding the data, that is the operand. So in this case we see that there is a two cycles from the memory. One is to find out the effective address, second one is to find out the data. So there is two cycle in the memory. Okay, now you see here, in one case we already discussed about where we are giving the register, and from register we are finding the effective address. So that is called the registered indirect. We already discussed this one. And another scenario, the address is the address from the RAM, from the memory, and from there we are finding the effective address. So this is called the memory indirect. We already discussed that if the indirect scenario, then we are using this or this bracket. Any one of these we are seeing in the instructions, it means that it is the indirect addressing mode. So you can see here example, this is the memory. So what is happening, this is the memory indirect addressing mode, because this is the memory locations. So what will happen in this case, it will go to the RAM, the location is 1005, from here some value will be there. Now that is the effective address. So from here they will go to the another, they will find the effective address, that is the address of another block in the RAM. From here they will find the data. So load R1 bracket 1005 means the 1005 is the address from where we will find the effective address. So I hope it is clear. If any question is there, please keep into the comment box.